Section 3.4, Slope-intercept form of a line. I'm going to start this section with a discussion similar to what your book has at the beginning. Let's take a look at some generic line in the coordinate plane. And let's say that we have this line that passes through some point, call it just xy, and has this y-intercept. And let's say that we're up at some number b on the y-axis. So the coordinates of this point would be 0, b. The reason we use a b is because when we talk about the x-intercept, we typically use the a. Let's find the slope of this line. The slope is the difference in the y's over the difference in the x's. The difference in the y's, y minus b, over the difference in the x's, x minus 0. Of course, x minus 0 is just x. We discovered in the last section that if we have an equation in two variables, a linear equation in two variables, solved for y, that the coefficient on x will be the slope. Let's see what happens when we solve this equation that we now have for y. Let's clear the fractions. Multiply both sides by x. Multiply both sides by x. And then to get y by itself, add b to both sides. Now this is solved for y. Let's go ahead and turn this around and write y equals . We started off finding the slope. By definition, we ended up with an equation that verifies that when we've solved for y, this coefficient on x is indeed the slope. But what else does it tell us? That the y-coordinate of the y-intercept is given by this what's going to be a numeric term. B is just some number. I didn't know what it was on my graph, so I called it b. But that y-coordinate of that y-intercept is going to be given by this numeric term. Here at the beginning of the section, slope-intercept form is given to us in a brown box, page 238, just below center of the page. In the brown box it says the slope-intercept form of the equation of a line with slope m and y-intercept 0b is y equals mx plus b, where m is the slope and 0b is the y-intercept. In other words, b is the y-coordinate of that y-intercept. So we have a certain form of a line now that we can look at and determine certain things about that line. In this particular case, it'll be very easy, given an equation already solved for y, to determine the slope and the y-intercept. So let's do a couple of those. In the homework set, number 8. She asked me to identify the slope and the y-intercept of the line. Identify the slope and the y-intercept. Well, the slope is the coefficient on x. When this is solved for y, this now looks like y equals mx plus b. And what's the value of m? What's the coefficient on x? It's this 1 that we can't see. And the value of b is also 1. So in this problem, she wanted the slope. Well, the slope is 1. And she wanted the y-intercept. The y-intercept is the point. Remember, it's not just a number, it is the point. 0, comma, whatever b is. So in this case, b is 1. So just being able to look at that equation once it's solved for y and being able to determine certain things about the line that we haven't even drawn, that's an incredible tool that we now have. Let's look at number 10. Number 10 is already solved for y. It already looks like y equals mx plus b, where m is what? What is the coefficient on this x term? What is it? We've had this question come up a few times already. When I have x over a number, what is the coefficient on x? If I were to rewrite this, would you agree that this is the same as saying 1/7 times x? And so the coefficient on x is 1/7. So our slope is 1/7. Our y-intercept is the point 0, comma, what's being added here at the end? This is plus what? This is plus a negative 5/14. So notice that b here is negative. So very quick and easy. Very quick and easy. Now in number 12, she's going to crank it up just a little bit. In number 12, she says, graph the equation of the line. But in a very specific way. Graph the equation of each line using the slope and the y-intercept. Number 12. Using the slope and the y-intercept. Now, I could pick 2 points, plug something in for x, get something for y, plug something in for y, get something for x, get 2 points and draw my line. That is not the goal of this problem. In this problem, she wants you to use the slope and the y-intercept to get your graph. If I wanted to test you on this concept, I would give you a problem that looked more like number 19 or any of those in that next batch. We'll do a few of those. But in this section of the homework, I want you following the instructions using the slope and the y-intercept to get your graph. So how do we do that? Well, first, let's identify the slope of this line. The slope of this line, this is already solved for y, so this looks like y equals mx plus b. The slope of this line is 4, the coefficient on x. And the y-intercept? The y-intercept of this line is the point 0, comma, and what's being added here at the end? What's being added? That's plus b, that's plus a negative 4. So I have my slope, I have my y-intercept. How am I going to go about graphing this? Let's go out to 4 in all directions to get started here. Well, we have 1 point. We have the y-intercept, the point 0, negative 4. Down here at negative 4 on the y-axis. In order to graph this line, I need a second point. Can this slope help me find a second point? Let's interpret this slope geometrically. That is, remember, slope is the rise over the run, the change in y per change in x. And in this case, the slope is 4. Well, let's call that 4 over 1. so we can see the whole ratio there. This is a slope of 4 to 1, meaning every time I go up 4, I go over 1 and land right back on the same line. Well, let's do that here. Let's go up 4 from the point we have. Let's go up 4, 1, 2, 3, 4, and over 1, there's 1, and that lands me right here at 1 on the x-axis. All I did was from the point that I have, go up 4 units and over 1 unit, and I found a second point. And draw your line. And that's all she's asking you to do. But we want to practice using the slope in order to find that second line. She has a blue box for us, back toward the beginning of the section, page 239. Graphing a line using the slope and y-intercept, she said, step 1, write the equation in slope-intercept form. Well, ours already was. It was already solved for y. Step 2, identify the y-intercept. We did that. Step 3, identify the slope. We did that. She goes on to say, use the geometric interpretation of slope, which is rise over run, what we did down here, to find another point on the graph by counting your up and over from this one point that we have, which is our y-intercept. And then step 4, of course, join the 2 points with a line. And I need arrows on both ends. It's not a line segment. So draw your line through those points and put arrows on both ends. And she suggests that you can pick some other point in order to check. Think of something to plug in here. If I were to plug in 2 for x, what would I get? 4 times 2 is 8, minus 4 is 4. The point 2, 4 should be on this line. And if this were a nice, neat graph, that would line up, if I were on graph paper, that would line up very nicely. And that would seem to check. So let's do another one. Number 14. We want to graph the line using the slope and the y-intercept. This is already solved for y, so I can see my slope and my y-intercept just sitting there. My slope is the coefficient on x, that's the negative 1/2. My y-intercept is the point 0 comma what's being added here at the end, a positive 2. I have these 2 pieces of information about my graph. I should be able to graph this line now. Get us a coordinate plane going. Again, I think I'll go out to 4 in all directions. We have our starting point, the point 0, 2, up here at 2 on the y-axis. And now we're going to interpret that slope geometrically. Now, if I think of this slope as rise over run, I can think of it one of 2 ways. I can put the negative in the top, call my rise negative 1, and my run is positive 2. Or I could think of that negative as being in the bottom. My rise would be positive 1. My run would be negative 2. A negative can live in any of those 3 places in a fraction, right? Chapter 1. Out in front, we can put it in the top or we can put it in the bottom. How should we interpret our slope? Let's try what I have here in pink. A negative 1 over a positive 2. What does that tell me I'm going to do? If the rise is negative, then I'm actually moving down. This is down 1 over 2. down 1 over 2. So from my point, from this y-intercept, if we move down 1 over 2, that puts me here at the point, what is that, 2, 1 on my graph. I came down 1 and over 2. I could lay my ruler down and be done. Draw my line, I've got it. What if I had interpreted it this other way? What if I had said, let me put that negative in the bottom? Well, then this is telling me to do what? Positive rise is up 1, and what? Back 2. I typically call to the right over, and when we're going to the left, I'll typically say we're going back. So if we start at our given point, our y-intercept again, and this time go up 1, back 2, up 1, back 2, that puts me here at the point that looks like -2, +3. I went up 1, back 2. And guess what? Lay your ruler down. All three of those points are on the same straight line. All three of those points lie on the same straight line. And in fact, it is accurate. This will pass through 4 on the x-axis. I can tell because if I go from my pink dot down 1 and over 2 again, I land right on that 4 on the x-axis. You don't need to do both, but pick one. Do you want to go down 1 over 2 or up 1 back 2? In this case, it really didn't make much of a difference. In some problems, it's easier. I mean, consider if we had a point that was way over here where we were starting on the far left of our coordinate plane. Wouldn't it be better to go down and over than to go up and back and have to draw more coordinate plane? If we're way down here at the bottom, it'd be better to go up than to go down. And so those are the considerations we'll make when we're thinking about where do I want to put that negative. All right, how about number 18? Again, the instructions. We're practicing using our slope-intercept form of a line. We're practicing that geometric interpretation of slope. And so the first thing I want to do is solve this for y. Solve this for y so that I can easily get my slope and my y-intercept. Subtract 6x from both sides. Subtract 6x from both sides. And then divide both sides by -5. Remember, this division is distributive. To divide both sides by -5 is to divide every single term on both sides by -5. We're distributing here on the right-hand side. This gives me y equals, negative over negative is positive, positive 6/5 times x, and minus 6. So now I can clearly see my slope is positive 6/5. My y-intercept is the point 0, and what's being added here at the end? A -6. We've got our slope, we've got a point. We can graph this. Let's head out to 6 in all directions. We'll start at the point that we have, which is our y-intercept down here at -6 on the y-axis, the point 0, -6. And now we're going to interpret our slope as rise over run. Now here's something to think about. Okay? My slope is rise over run. And this 6/5 could also be interpreted as a -6 over a -5. That is, from this given point, I can go up 6 over 5, or that would be the same as going down 6, back 5. Now, from this point, it is much more convenient to go up than down, so I'll take this first interpretation. But if we were starting near the top of the graph, or near the far right-hand side of my coordinate system, it might be more convenient to consider this down and back instead of up and over. From this point, we need to go up 6 units. 1, 2, 3, 4, 5, 6 lands us right at the origin, and over 5. 1, 2, 3, 4, 5 puts us right there at 5 on my x-axis. We went up 6 and over 5 units. Always easier to count on graph paper when you've got that grid. But we found our second point, and so we're ready to draw the line through those points. Now, like I said, if I'm going to test you on this concept of graphing, and I am going to test you on this. If I'm going to test you on this concept of graphing using this geometric interpretation of slope, I'm not going to give you an equation. How can I tell that you are using the slope instead of just figuring out 2 points? I mean, look how easy that would have been here. Okay, forget all this for just a minute. And let's say that the only thing you were asked to do is graph. Well, the most straightforward approach would be, let's find 2 points. The easiest 2 points to find, if they're not both at the origin, are the intercepts. X-intercept when y is 0, y-intercept when x is 0, like we've been doing. Plug in 0 for y. This term disappears to leave 6x equals 30. X must have been 5. Plug 0 in for x. This term disappears to leave negative 5y equals 30. Y must have been negative 6. I've got my 2 points, which just happened to be this time the 2 points that were involved in my having done this a moment ago. But there are my 2 points. Draw the line. Done. If all it says is graph and you have that equation, this is probably the slickest way. But again, in problems 11 through 18, that's not the skill that we're wanting to practice. If I'm going to test you on this geometric interpretation of slope, I'll give you a problem more like number 22. The instructions say graph each line passing through the given point and having the given slope. There's no equation. The only reasonable way at this moment to find a second point, so I can lay my ruler down and draw that line, the only reasonable way to find that next point is to run with the slope. So let's get our coordinate plane ready. Let's head out to 5 in all directions. And on any quiz or any test, if I want you to graph something, I'm going to pre-print that coordinate system on the paper. It'll have a nice little faint grid behind it to help us as well. But I will provide the coordinate plane that you can graph on. Our starting point, our only point that we have right now, is the point 2, -1. That's down here in the 4th quadrant. Over to 2 in the x direction and down 1 in the y direction puts me right there. Now we need to figure out, do we want to call this a -1 over a +3? Or would we rather call this a positive 1 over a negative 3. I think we're better off going up and back. Not much better off. I don't think it really makes much difference in this particular problem, but I think I'm going to go with up and back. Up 1, back 3 is what this is telling me. Rise over run. Positive 1, we go up 1. A negative 3 from our run, we're backing up 3. So from this given point, let's move up 1 and back 3. 1, 2, 3. That puts me back here at negative 1 on the x-axis. So now I have my 2 points, and I am ready to graph my line. If I had chosen to interpret my slope with the negative in the top, what would I have done? I would have gone down 1 over 3. Down 1 over 3. That would have put me right here at the point 5, negative 2, which we can see we would have drawn the same line if we had done that. So in this case, either would have worked just fine. But remember, sometimes you're near the edge. You're starting near the edge of the coordinate system, and you may want to consider which of the two interpretations will serve you better. Let's look at number 28. Number 28, she wants us to graph the line that passes through the point 3, 2 and has a slope of 0. Slope of 0 already tells you what? That this is a line that neither rises nor falls. This is a horizontal line. This is the horizontal line that will pass through the point 3, 2 in the coordinate plane. The point 3, 2 right there. And so, done. The horizontal line that passes through that point, right there he is. Can we give geometric interpretation to that 0? Well, can't I think of this as 0 over 1, or really 0 over anything? And what does that say? Up 0 over 1. Up 0 over 1. If I start here and I go up 0, meaning I don't move up or down, and all I do is go over 1, where does that put me? Right there. Up 0 over 1. Up 0 over 1. Or up 0, back 1. Up 0, back 1. And it will draw out this horizontal line. I don't really need to make that interpretation because I know that a slope of 0 is going to be horizontal. And so plot that point and get that horizontal line through there. Of course, because this is the point 3, 2 where we started, I had better be passing through what? Where y is 2 on the y-axis. All the y values on this line have to be 2 for it to be horizontal. Look at number 30. Here we're given an undefined slope. What I often call no slope. Well, we already know what that means, don't we? A line that has an undefined slope, that's a vertical line. And so, this one's going to be just as quick and easy. These vertical and horizontal lines are so quick and easy. They are easy points to earn. They're also easy points to lose if you don't get these concepts down pat. The point that we're given is the point 3, negative 2. That's here in the fourth quadrant. And because the slope is undefined, I know that that's going to be the vertical line. And of course, all of the x's on this vertical line will be 3, so this had better pass through 3 on the x-axis. Now, Can we give geometric interpretation to this slope? As a mathematician, I have to say undefined is not a number. And so I can't look at that as a fraction. Well, let me step out of that role for a minute. And let's consider that undefined, as a physicist, I might say undefined, that's like 1 over 0. What does that tell me to do? If this is my slope, which mathematically we would simply say this has no slope, the slope is undefined, and that's the end of it. But as a physicist, I want to ponder this just for a second. This would tell me go up 1 over nothing. Up 1 over nothing. Well, if I start here at this given point and I go up 1 but not over, where am I? I'm right above where I was, immediately above. Up 1 over nothing. Up 1 over nothing. And I'm tracing out this vertical line. But as a mathematician, I don't interpret it that way. As a mathematician, I say, oh, undefined, that's a vertical line. Done. As a physicist, I go, isn't that interesting if I think of it as 1 over 0? Easy points to earn. Easy points to lose if you are not vested in knowing these horizontal and vertical lines. All right, number 42. In number 42, she says, write an equation in slope-intercept form, if possible, of the line passing through the given point and having the given slope. Number 42. Well, guess what, guys? There's my y-intercept, there's the slope, and I have the equation of a line, y equals mx plus b, that uses the slope and the y-intercept. Y equals, the slope is -5, so -5x, and plus b, plus the y coordinate of my y-intercept. And that one's done. Given that slope and that y-intercept, I can come up with the equation of that line in slope-intercept form. Now, that one was very straightforward and easy. They won't all be so. Let's have a look at number 48. Now in number 48 we have the slope, that's great, but we don't have the y-intercept. We just have some other point on the line. We could graph this like we've been doing. We could graph this, but that's not going to get us much closer. But think about this. If I can graph it, it must have an equation. In this problem, if I just had a y-intercept, I would be in business. I've got my slope, I just need a y-intercept. What do I have? I have an x and a y of one of the points, and I have my slope m. That's all but one piece of y equals mx plus b. I can plug in for x, y, and m and solve for b. So let's do that. Y is 1 equals, m is -2 times x for this given point is -3, and plus b, we're solving for little b. 1 equals, what is that, 6 plus b. Please make sure your 6's and your b's can be told apart. They should not look similar enough to each other that you're not sure what that is, especially when someone else is reading what you've written. Subtract 6 from both sides, and b is -5. I have all the information I need now. The y-intercept of this line which we weren't specifically asked to find. The y-intercept would be the point 0, negative 5. I'm ready now to plug into y equals mx plus b, because I've got my m and I've got my b. Y equals the slope, negative 2x, and plus b. Plus a negative 5, we simply write minus 5. And there's the equation of my line. I can check this very quickly. Does this line have a slope of negative 2? Yes, right there I can see it. Does this line pass through the point negative 3, 1? Well, that means negative 3, 1 should be a solution to this equation. That checks. So that is the equation of the line that passes through this point and has that slope. Number 60. In number 60, the point given is negative 3, 3, and the slope given is 0. So we already know what? This is going to be a horizontal line. Horizontal lines look like what? Y equals some number. Well, what number? Well, picture this on the graph, okay? We have the point negative 3, positive 3 right there. And this is the horizontal line through that point. So, this is the horizontal line that passes through 3 on the y-axis. Every point on this line has a y-coordinate of 3. So this is y equals 3. And I'm done. Now, if you want to use the same method that we've been dealing with and say, well, y equals mx plus b, you could plug 0 in for m, negative 3 for x, 3 for y, and discover that b, well, I mean, that should be fairly easy to see. 3 equals 0 times negative 3 plus b. That's 3 equals b. And then I could go and I could plug in my value for m and this found value for b. 0x is just 0 plus 3 is just 3. And so there would be my final answer. When it comes to vertical and horizontal lines, though, it is so much easier just to say, this is a horizontal line, and on this horizontal line, all of the y-coordinates must be the same. They've got to be the same as this original point. All the y-coordinates have to be 3. Y is 3, and be done with it. Because what about a problem like, let's back up, number 58. In number 58, we have the point 0, 5 and an undefined slope. You can't plug that slope in anywhere because undefined is not a number. So you cannot plug that in to y equals mx plus b. So your best bet is to realize that undefined means what? I've got a vertical line. This is going to be the vertical line that passes through the point 0, 5. The vertical line that passes through the point 0, 5. Well, that turns out to be the y-axis itself. It is the vertical line that passes through what? Look right here. All the x's on this vertical line must be the same. They've got to match this original point. All of the x's on this line must be 0. This is the vertical line that passes through 0 on the x-axis. And so there's the equation of that line. This is why in the instructions she said, if possible. She said, write the equation in slope-intercept form if possible. Well, in this problem, it's not possible to solve for y. But we can give its equation, x equals a number, that's a vertical line that passes through that number on the x-axis. In this case, it's the y-axis itself, which is that vertical line passing through what? 0 on my x-axis. In the next section, we're going to take a look at another form of the equation of a line and be able to do even more. So for now, practice this, get this down, because we're starting to turn these problems inside out. We really need to be down pat with the first 3 sections in this chapter in order to now kind of turn these problems inside out. Instead of given an equation, find some points. Given an equation, find the slope. Given an equation, graph the line. Now we're being told, hey, here's a point and a slope. Find the equation. Find the equation. So that's our look at 3.4. Next time we'll have a look at point slope form of a line.